We are jumping right in tonight, everybody. Hello, hello. Thank you all for being here. We're streaming. We are streaming today. We're going to do a short one. This is going to be a short day today. All right. Here we're going to switch over to Hill. Boom. As you can see, it is 12:18, which is actually not as late as it's been for me a number of times before, but I want to not do this very late. But I want to keep up with it, not go have it. I don't want to go too long without having it be fresh in my brain. So there's like a hair on my nose. Did you get it? I think I might have got it. Yes, I'm wearing the same shirt as last night. Okay, forgive me. But we're going to do this one, and we're going to do the exercise. I looked ahead briefly.
Hello and welcome.
And to see that it's 8 minutes long, 8.5 minutes long. So, yeah, I don't want to take too long on the stuff here. So let's just kind of get right into it, and we'll get this show on the road. All right.
So now we're going to dig into strings a bit, and we've already looked at how.
Let's slicing strings. We can also look at any continuous section of a string using a colon operator. The second number is one beyond. The second number is one beyond the end of that. My brain's struggling tonight, folks. Forgive me. I'm not really in the coding mindset right now, so I need to kind of settle in here. We can also look at any continuous section of a string using a colon operator. I don't really know what that means. Continuous section of a string using a colon operator. The second number is one beyond the end of the slice. The second number is one beyond the end. Up to but not including. If the second number is beyond the end of the string, it stops at the end. I don't understand any of this. What the heck? Okay. S equals Monty Python. Print S. Oh, okay, so it prints print S, and then it indexes 0 to 4. So colon is like the range. Wait, the second number is one beyond the end. Oh, so I get it, up to but not including. So 4, it's up to but not including 4. So that's why it's just mont, right? So this is 6, print S, 6, and up to but not including 7, which is Y. So it's not including Y. That's why it's just P. If the second number is beyond the end of the string, it stops at the end, which is why Python. Okay. Oh, so continuous. Okay. That confused me for a bit, but I think I get it.
How you can pull out a single character in a string, and now we're going to look at what we call slicing, and that is pulling chunks of a string out. And again, we're going to use the square bracket operator, and And so and the way I say it is sub. S sub 0 through
Sub.
4. That's how I read this. S sub 0 through 4. So I look at the colon as through. I look at the brackets as sub. And so S sub 0 through 4 says start at position 0 and then go up through, but not including 4, right? So we don't include 4. So that's probably the hardest part of this. Up to, but not including. Up to, but not including. This seems counterintuitive, kind of like starting at 0 seems counterintuitive, but after a while, you get used to it, and there'll be situations where you're writing code like, oh, that's why that works better. But just for now, remember it. Up to, but not including. It's just kind of a little thing. We'll come back to when that is useful for us. 6 through 7, well, that ends up being starting at 6, up to, but not including 7. So that's why we only get the P out. Now, one thing that Python is pretty nice about is it's not going to give you a trace back. We might expect that 6 through 20, well, there's no 20 characters, but it's like, that's okay. We'll just let you stop at the end, and we'll start at 6 and go all the way to the end. Oh, no trace back. It's almost disappointing sometimes when Python doesn't trace back, when you think, if you're so obsessed about everything, I would have traced back in that situation. But hey, I guess if you're allowed, you're allowed. And so there we go. Now you can eliminate or omit the...
Okay, hold on a second. If we leave off the first number... Oh, we heard about this from Corey. If we leave off the first number or the last number of the slice, it is assumed to be the beginning or the end of the string, respectively. So S equals bounty Python, print S sub. So that would be just up to, but not including 2, starting from 0. So that's mo. That is 8 on. T, so it's on. And then, oh, that's the whole thing because it's interesting. Huh. So it has no beginning, or it starts at the beginning, stops at the end, whole thing.
The first or last, if you eliminate the first, it assumes the beginning of string. If you eliminate the second, it assumes the end of the string. And why you would do this, I don't know, but that's from beginning to end, so it's the whole string. So whole string, 8 through the end is thon, and up to but not including 2 is mo. All right, so you get that. So that's pretty simple. Once you've got the rest of slicing and the rest of string indexing, the notion of eliminating the first or the last of the colon expression, the first or second of the colon expression, I think is actually pretty intuitive, pretty nice. We've already been...
When the plus operator is applied to strings, it means concatenation. Add and crud together. Hello plus, or B equals A plus there. So B, ooh, hello there. C equals A plus, so that's the space, huh? That's what you need to do for the space.
Concatenating strings together, we overload the plus operator, and there is no space added. Remember, when you're doing print, x comma y, this comma does turn into a space, but that's not what's happening here. There is no automatic space being added, and so we see hello in there, and it just is hello there with no space. And so if we want, we just have to concatenate the space explicitly if we want to put spaces into strings. The problem is if this, you might think it's more convenient to add a space with a concatenation, but then you have to think, well, what about if I want to concatenate things and not put the space in? Then I'd need a different operator. So that's kind of why it works that way.
Wait, what?
Here, there is no automatic space being added, and so we see hello in there, and it just is hello there with no space. And so if we want, we just have to concatenate the space explicitly if we want to put spaces into strings. The problem is if this, you might think it's more convenient to add a space with a concatenation, but then you have to think, well, what about if I want to concatenate things and not put the space in? Then I'd need a different operator. So that's kind of why it works that way.
We can use. Why do you need to use a different operator if you want to add something and not have the space? Doesn't it just not have the space automatically by adding? Concatenating? I'm going to choose not to think about that too hard. We're moving on. Using in as a logical operator. Oh, excuse me. The in keyword also can also be used to check to see if one string is in another string. The in expression is a logical expression that returns true or false and can be used in an if statement. Fruit equals banana. N in fruit. Oh. N in fruit is true. M. What? In fruit. What? How the? Why is N true and M? Oh, because it's not in there. Duh. Is basically asking, like, is N in fruit? Which is banana. And it's like, yeah, it is. Is M in banana? Nope. Is Nan in? Okay. If A in fruit. Found it. Found it.
Use in differently as a logical operator, so we're using it as an iteration structure in for loops, but we can also use it as a logical operator in if statements. So it's kind of like the double equals or not equals or less than or equals or something like that. It's like those guys, and so it returns a true or a false. Is N in fruit? So that's a question, and the answer is true. Is M in fruit? No, that's the answer to a question. Is Nan in fruit? Doesn't have to be single character, can be more than one character, and the answer is true. And then you say something like, if A in fruit. And so this is the logical value that returns a true or a false, and yes, we found it. So that becomes true in this particular case, so it runs the little indented bit. So in is an operator in this particular situation. In a for loop, in means something different. And we'll use in for other things as operators, as logical operators coming up in a bit. You can compare
string comparison. He's gone through a lot of slides. String comparison. If word is banana, print all right bananas. If word is greater than banana, print your word plus word comes before banana. L if your word is greater than banana. Print if word is greater than banana, print your word plus comes after banana. Else print all right bananas. Greater in what way? Less than in what way? What?
strings, and this has to do with the character set of your computer, the character set that Python is, but in general, it is lexicographically less than and lexicographically greater than. Uppercase and lowercase are a little weird. I think when we used the max function earlier, the way my computer was set up, uppercase was less than lowercase. But in general, uppercase is less than lowercase. But in general, it's bad to assume case. But uppercase was less than lowercase. But in general, uppercase is less than lowercase. But in general, it's bad to assume case, but there is a deterministic way to sort strings. You can, have something equal to or less than or greater than, and all those operations work naturally. The less than and greater than, you have to kind of be aware of uppercase, lowercase, things like where punctuation sorts less than or greater than letters. That's kind of unpredictable and depends on the character set of.
I'm just confused about. Oh, I get it. So it's comparing if your word is banana, which it is. I mean, it is. If word, why is the if there? Oh no, that's fine. If word banana, which is if word is greater than banana, but it isn't because it is banana. So all right, bananas. It's still a bit confusing to me, I'll be honest.
Of your computer, and something you just play with and figure out. If you're doing sorting stuff by first name and last name, as long as the case is kind of the same, if you were sorting Chuck with an uppercase and Glenn, the fact that these uppercases, they'd sort right and these lowercases would sort right, but if you were to subdue instead lowercase Chuck and uppercase Glenn, then that would sort weird. As a matter of fact, the G would come before that. And so case can mess this up. But in general, other than case and special characters and other things, it technically works. It's just hard to kind of predict it. A lot of what we do is use the string library.
Oh, man. Python has a number of string functions which are in the string library. These functions are already built into every string. We invoke them by appending the function to the string variable. These functions do not modify the original string. Instead, they return a new string that has been altered. Excuse me, man. Ugh. My brain's not really with coding right now, folks. Forgive me. Greet equals hello Bob. Zap equals greet dot lower. Oh, again, this is what Corey was telling us about. Print zap. Hello Bob. Greet. Hello Bob. Print hi there. Lower, hi there.
And so the strings are objects, and we'll talk later about what that really means. And objects have these things we call methods. So a string object has some built-in capabilities, and one of the built-in capabilities that the string object has is, here is a string object, and because greet is a string object, if we said type, we'd see that it was an str. Dot lower says, hey, dear string, make a lowercase version of yourself. It's like calling this function lower and passing greet into it, and then give that back to me. Now, it doesn't actually change greet. It gives me a lowercase copy. So here I have hello Bob with an H and a B uppercase, and what I get back in Zap is hello Bob all lowercase. And note that greet is unchanged. So hello Bob is still there. And you can even call these methods on constants. So this is a string object, quote, hi there, quote, dot lower. That says, call lower on this bit of string and give me back a lowercase version of it. And so it prints out as the residual return value. This is like a function call. A method call is a kind of special form of a function call. It's a function call where you say the thing dot the function name rather than function name passed in as a parameter. Like len, for example, is non-object oriented. len of x, that's not object oriented. Object oriented would be x dot something, parenthesis. But so constants are objects as well, and taking the lower gives us back lowercase hi there. And so that's just one of the things that you can do in the string library. These are built into string variables and constants. They're just always there. As soon as you make a string, they're part of it. And when you do type and it says it's class str, we'll get to object oriented. Don't worry, we'll get to object oriented. Okay, and so you can do things like use the type.
Dude, this is all Corey, man. That was cool. That it's all coming together, kind of. Not that we know what all these mean, but stuff, hello world type stuff. Oh, type. I hope he tells us what that means. Then that gives us all the stuff we can do with it, I think.
If you're just look, this used to say type stir, but it's class stir. Kind of, this is more of an the word class is an object oriented concept, but it is a string. So you can do type, and we'll get to object oriented. Okay, and so you can do things like use the type. If you're just look, this used to say type stir, but it's class stir. Kind of, this is more of an the word class is an object oriented concept, but it is a string, and you can use the dir, and of course there's extra stuff up here, and this is showing all the different methods or capabilities, things we can do to strings. So, x dot something, parenthesis. Well, what can we do there? This is all of those things that we can do to x's that are built in and come with come with strings when we build them. And Python, of course, has great documentation online for all of these string methods and what they do and how they work and why they work the way they do.
Cool.
And so here's some of that Python documentation. We'll look at a few of these, but don't hesitate to say Python string uppercase, and then we're like, oh yeah, that is upper, right? And so here's a few things that we can
Capitalize, center.
Do and use. Some of the ones I use a lot, and we'll look at each one of these things.
Find.
So the find operation.
Replace lower strip. Wait, R strip. Strip upper.
Do and use. Some of the ones I use a lot, and we'll look at each one of these things with
so
X's.
Didn't really get a class. Is that type stuff? It just tells us it's a string, right? That's what the class is. I think that's what that means.
Come with is upper, right? And so the find operation said
searching a string. We use the find function to search for a substring within another string. Find finds the first occurrence of the substring. If the substring is not found, find returns -1. Interesting. Remember that string position starts as 0. Fruit equals banana. POS equals fruit dot find in parentheses NA. Oh. Print POS. Print NA. Oh, AA equals fruit. Oh. Dot find Z. There's no Z, so therefore -1. But this, why is it 2? NA. Oh, the first occurrence of the substring. First occurrence, which in this case would be N. Cool.
As find me a substring within a string, right? Find me a substring within a string. So find me the first NA and give me back the position. So that gives me back 2. And then I can say, go find a z in there. Well, there's no z, and so it returns me -1. So that's what the find does. So we're going to use this kind of stuff a lot, and we do a lot of looking in strings. Converting things to upper or lower case.
You can make a copy of a string in lowercase or uppercase often when we are searching for a string using find. We first convert the string to lowercase, so we can search a string regardless of case. Using hello Bob, NNN equals greet upper. Do you have to make it all upper? No, you don't need to print Bob print NNN hello Bob. www equals greet.lower. Print hello Bob.
There is an upper method and a lower method.
Oh.
So greet.upper, and that means the uppercase NNN is hello Bob. Greet.lower, that means that www is the lowercase hello world, and greet is unchanged. Greet is still hello Bob with upper and lower, because each of these methods basically say, I'm going to give you back a uppercase copy or a lowercase copy of the original thing without changing the original thing.
Understood.
Search and replace is super useful.
Cool. The replace function is like a search and replace operation in a word processor. It is super useful. I can imagine how that would be useful. It replaces all occurrences of the search string with the replacement string. Greet hello Bob. NSTR equals greet.replace Bob, comma Jane, print NSTR hello Jane. Okay. So it's everything after the comma. That is the replacement. So it's like replace Bob with Jane in that top situation. NSTR equals greet dot replace O, comma X, print NSTR. Oh, so it takes the O's and replaces it with the X.
Super duper useful. And it's pretty clean. Here we have a string, and we use the replace method. In this case, we're passing in the old and the new. Bob, replace all Bobs with Janes. And so that takes this hello Bob and turns it to hello Jane. Again, greet is unchanged. Greet is unchanged. And it does more than one thing. So this says go find, well, let's clear that. This says go find all the O's and replace all the O's with X's. And so it goes and finds 2 of them, and then out come 2 X's. And so that really is replace is not just replace the first one, but replace all of them. White.
Stripping white space. Strip. Like in the hacker rank one. Wasn't that a strip? Oh, goodness. Yo. Stripping white space. Sometimes we want to take a string and remove white space at the beginning and or end. L strip and R strip remove white space at the left or right. Strip removes both beginning and ending white space. So it just gets rid of spaces? What's white space? Greet equals... Oh, is that like space? Hello, Bob space? Greet. Oh. Okay, so it's just at the tail in the front. Greet L strip. Takes it at the front. Greet R strip. Takes it at the end. Greet strip. Moves it at the front. And oh my word.
White space, as we'll see, is a big deal. And white space is not just blanks, although the most common thing, but it's also sort of non-printing characters like tabs and new lines and other kinds of things. Okay. And so we have a number of different ways to strip white space. So here we've got some spaces at the beginning and spaces at the end. And we print out, we do an L strip, and that throws away the spaces at the beginning. That's the left, so that's a left strip. It all takes any, if there's nothing there, it doesn't harm it. R strip means throw away all the blanks on the far end. And then strip says go take both sides for strip, and so that pulls out all the spaces on both sides. This will be useful because sometimes when you're tearing stuff apart, you'll find yourself getting extra spaces. Sometimes at the beginning, sometimes at the end. And it can be tab or new line. It's sort of white space that is kind of not visible, clear. That's what white space is. It's like if you were on a piece of paper, it's the white space. It's like X. Well, that's not white space, but right here, oh, that's white space. It's any character that doesn't cause printing to happen, if that makes any sense. It's any character where nothing would be at the end. And it can be tab or new line. It's sort of white space that is kind of not visible, clear. That's what white space is. It's like if you were on a piece of paper, it's the white space. It's like X. Well, that's not white space, but right here, oh, that's white space. It's any character that doesn't cause printing to happen, if that makes any sense. It's any character where nothing would be printed. And there are characters like that.
Okay.
There's like even bell characters, but we don't use them very much. We can ask a very
doesn't cause printing to happen. Okay, I think I understand what he's saying. Prefixes. Line, please have a nice day. Or line equals please have a nice day. Line dot start with please. Starts with. Oh, and that returns a true. Line dot starts with P. Lowercase p. P. Oh, and it's false.
Conveniently, we can say, hey, does this line start with a particular string? And so, line, does this is a question, going to return a true or a false. Does this line start with please? And the answer is true, it does start with please. Does this line start with a lowercase p? No, it does not. And so again, you use this in the context of if something, colon, some block of text.
I get that.
It's a block of code. So we can...
Oh, bro, am I covering this up? Hold on a second. There we go. We'll hang out kind of right here for the moment. From Stephen... Parsing and extracting. Oh my gosh, what the heck is this? Oh my word. From Stephen.Marquard at uct.ac.za. Data from Stephen. At pos equals data.find at. Oh, that's awesome. Okay, I get that print at pause that gives. So 1, 2, or 0. I want to see this here. Hold on a second. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Exactly. Awesome. S or sp pos equals data.find space add pos. What? What does that mean? Data.find. Is the next space after? It's got to be, right? Host dot or host equals data sub. Oh my gosh, at posts. Yo, this is getting bonkers, bro. Host equals data sub at post plus 1 colon suppose. So what? At pos plus 1 through suppose. print host. So data. I still don't get what this is, right? So add post those 21 plus 1, so it's an add post plus 1. Just U through as, yeah. So that's why it includes from here through here. I get it. I just don't understand this. So hopefully
combine these things to tear stuff out. And so let's assume that what we want to do in this case is we want to take a from line. This is from an email format from a mailbox. And this has got the from with a space and the person's email, and then @ sign in the school they're from, and a space, and then the rest of the stuff like when this mail was sent. And this is a real mail message from this guy, Stephen, from the University of Cape Town in South Africa. And it's really Stephen. And this really is the first line of a file that you'll get to know pretty well by the rest of this course. Hi, Stephen. We like you. You are the example in my class and have been for a long time. People actually who know Stephen have taken this class, and they're like, Stephen, I saw your picture in the class. So if you're ever in Cape Town at the University of Cape Town, say hi to Stephen and tell him that you saw him in the class. But okay, that's neither here nor there. What I really want to do is I want to extract his school from this email line. Okay, so now eventually we will do things like the data will come from files, but this is still chapter 6. So this is the data we're going to search through. And so we can say, hey, let's go find the @ sign. Search up to this position and find the @ sign. So data.find @ sign. And give me back where that's at. That's in position 21. This is position 0. Then what we're going to do is we're going to look for the next space after the @ sign. So we're going to start at the @ sign and tell find to start here. And
what? How do you know? Hang with it, man. Okay.
Look forward until it finds a space. The @ sign. So we're going to start at the @ sign.
Why the heck does that start there, bro?
And tell find to start here and look forward until it finds a space.
Is that just the starting point for find? Is after the comma? Am I thinking too hard about this? I mean, that must be what it is.
So data, and give me back where that's at. That's in position 21. This is position 0. Then what we're going to do is we're going to look for the next space after the @ sign. So we're going to start at the @ sign and tell find to start here and look forward until it finds a space. So data.find, look for a space starting at the position of the @ sign, and then that'll be in position 31. So 31 is what we get in the space position. So now what we have is we have in two variables, we have position, the position of the @ sign and the position of the space after the @ sign. Now what we really want is this bit right here. So we have to go one beyond the @ sign, and we don't want the space. So we say, we're going to use slicing here, data sub at position +1 up to but not including the space. Oh, smiley face, because we didn't have to say space -1 because that is up to but not including. And so we get that little bit right there. So we don't have to say -1 there because this is not actually included. The thing that's at the position of the space is not included. So that's already a little benefit for the up to but not including. And so when we print this variable out, host, we get exactly just the school that Stephen works at and probably went to, as a matter of fact. I don't know if he went there or not. So this is just kind of...
Okay, 2 guys with strings. Python. Oh, I don't know if I want to mess with this. We're just going to watch this.
A note for non-Latin character sets. All programming languages from the 60s on tended to work in what we call the Latin character set, which is United States and England and Europe, and lots of places use this ABC character set and the special characters. But it's really common to want to use different characters. And so if you're going from Python 2 to Python 3, and we'll talk about this a little later when it matters more. Luckily, we're in Python 3, and so Python 3, one of the big things about Python 3 is that all the internal strings are Unicode. In Python 2, there was sort of some confusion as you went between strings. And this is just a little bit of code, and so I'm putting a in here, some Asian characters. This is Korean, actually. Asian characters into X, and then I say what kind of a thing this is, and that is a string. And then there's this Unicode, and this comes from Python 2. If it's a Unicode operation, it's still a string. Whereas in Python 2, if you put international characters into X, then it was a string, and then there was a separate kind of a constant called a Unicode constant, and it was a different type. And there was ways that you had to mess with these Unicode variables as you did things like read them from files and put them back into files and did other things. So it was much more difficult in Python 2, but we're doing in Python 3, and in Python 3 it natively understands non-Latin character sets, international Asian character sets, Spanish, French character sets in Python 2, but we're doing in Python.
Sorry.
We're doing in Python type, and there was ways that you had to mess with these Unicode variables as you did things like read them from files and put them back into files and did other things. So it was much more difficult in Python 2, but we're doing in Python 3, and in Python 3 it natively understands non-Latin character sets, international Asian character sets, Spanish, French character sets. And so this is a good thing for Python 3, and this is one of the real benefits of using Python 3. And as we start doing stuff where we're exchanging data with the outside world, this will come into play, and I'll have to show you how to use it. There was weird things that you had to do. It just makes a lot more sense in Python 3. Okay? So we've talked about strings. We learned about the string. We're converting it. We've done a whole bunch of stuff, and this is, again, we're not yet doing anything super useful. We're learning sort of how to like slice and dice, even though we're sort of not making the meal yet. Up next, we're going to talk about files. We're going to read some data, and we're going to slice and dice and use all the things in the next chapter that we've learned up to this point. So see you in a bit.
Okay. Remember how he said next chapter, which was 7. Next chapter is where it'll all like make sense. So starts then. What is the value of I in the following code? Word equals banana. I equals word.find and A. So first occurrence and A. So 0, 1, 2. Yeah, the world rejoices. Cool. Reading files. What does it handle? One step at a time. I don't want to get like this seems daunting to me. Reading files. That's all right. We've handled it thus far. Let's get into this.
Welcome to Python for Everybody. My name is Charles Severance, and I'm the author of the book and the teacher of this class. In this particular session, we are going to do exercise 6.5 from the textbook. It's an exercise in parsing text strings. And so the basic idea is we're going to see strings of various kinds and various lengths, and we're going to want to extract pieces of them, okay? And so the idea is to somehow get this part out and then convert it to a floating point number. This is a proxy for later things where we're actually reading files or reading stuff off the internet, but parsing...
Hold on, before I do that, okay, we do have HackerRank. So I'm going to save that and get rid of it. And gobbledygook, and we'll do 8. There we go.
strings is an important thing for us to do. Okay? And so let's take a look at a couple of different ways to do this. So let's go ahead and get started. Let's go bring up our atom. And I've got it open nicely to the right spot here, and I'm going to make a new folder. Hopefully by now you're finding atom EX0605. Atom, or whatever your programmer editor is sort of a powerful tool. I'll close this one. File, new file. A powerful tool that lets you sort of save a lot of keystrokes, etc., etc. Print exercise 6.5, just for yucks.
Just for yucks.
Yes. Size and then file save as. And again, until I save it, it's not going to have the pretty colors. I'm going to save it in 605. EX0605.py. And now it has the pretty colors. And here I am. Now, I've been doing these, and so now I'm actually already in a directory. So let me show you how to do relative directories. So I'm in this path right here, and I can use, both in Windows and in Mac and in Linux, I can use the command cd ... That sort of thinks of the one before, the one that came before.
Yeah.
And so now I'm up one directory. And if I do an ls, I will see that this new EX0605 that I just created in this directory from Atom is already there. cd EX0605. In the next chapter, we'll be talking about files. And this is where you really need to know this concept of folders and files. So ls, and I'm going to run Python 3 EX0605.py. There we go, exercise 6.5. So we're sort of in the right spot. We've got this going and we've got this going. Pretty soon we'll be putting stuff in these directories that need to be there, and you'll see how all that'll work in a second. Well, in the next chapter, where we've got to know all this stuff. Okay, so we'll just grab this first line here.
Oh, shoot.
And paste.
Okay. Hold on. You do it just. Okay. I won't be able to copy it directly, so I'll need to do str equals x. Excuse me. Confidence. Oops. Oh my gosh. I ruined everything. Oh my word, what is happening? Oh, this is not what I wanted. Can I close this, please? Thank you. What is happening? Can I please minimize this? Wait. Oh no. I remember. Was it shift? No. F5. I will need to look this up, fam. Hold on. How to make it. I'll bring it over here. How to make white rice in a rice cooker. How to make. I'm totally forgetting what this even is. Visual Studio Code not full screen. Shift Alt Enter. Shift Alt Enter. Whoops. It's not doing it, fam. Whoops. Control Alt Delete. Shift Alt Enter. Is it Control Shift Enter? Yo, I can't believe. I should just be able to grab this crud, man. You know what I'm saying? Here we go. F11. What? Is it Shift F11? F11? It has to be one of the Fs, right? I'm trying them all. I hope I'm not like just screwing up everything, dude. I just made everything go away. Okay, you know what? Let's just... Oh, okay, that's back. Oh, I can't believe I did this. Why? I did this before, that's the problem. F1 full. Oh, there we go. Okay, we're back. Sorry about that little detour. Confidence. Where were we? Okay. 0 E475. Is there another space there? It looks like it.
Stat in. Print stir.
Okay, so hold on.
So
We need to find.
let's run it. And there we go. Actually,
Use find and string splicing to extract the portion of the string after the colon. Okay. So, hold up. Okay, we're back here. Let me back out of the way. Sol, just for solution, right? Equals find the first occurrence. Oops, first occurrence 0.8475. So if I just freaking run this, that's not what I want it to look like, though. There we go. Nope.
there's supposed to be a space right there.
Find sub.
So I don't know why this space didn't get copied and pasted from my copy and paste. So I'm going to put that space in. There's supposed to be a space right there,
Did I put a space? I feel like I did, yeah.
I think, but we'll see. So the key thing is, if you look at the lectures from this section, you can like look for things and you look for a pattern. And so what I'm going to do is I am going to look for a pattern that says find me a colon. Okay, and I'm going to say,
okay, here's the key.
where is there a colon equals stir.find.
Did I get any of that right? Okay, no, I did. Oh, it's parentheses. Colon? No, that's not right. Is it colon? Oh, it is a colon? Whoops. That's not what I wanted. Sorry. Some editing work that I'm doing. Yeah, that's actually stuff that I already did. I can close out that. Anyway, I'll do that later.
And then print out IPOs.
Okay. Print 18. So now we'll do opos, just because equals str um 18 plus 1. No. Yeah, no, plus 1 through. That's it. No. Oh, print opals. Might be. Hold on. We did it.
So I'm going to say, where in this string is there a colon? That's going to give me the position and offset of that. So that says that the colon is in position 18. Now, it's not always going to be 18. Sometimes these strings will be a little bit different. Okay. So the next thing I can do is I can say a small piece of this string is do stir, and then starting from that position, I pose through the end of the string. And then we're going to print that out, print out the piece. And when I'm doing string parsing, tearing strings apart, I tend to have a lot of situations where I print over and over and over again. So now let's see if that piece is the right piece. And the answer is it doesn't quite look right, because see, I've got that colon there. And that's because it says start at 18, position 18, wherever that is.
Where the heck to get piece, man? Piece. Oh, because then you just did I post and everything after I post, which is okay.
Keep on going. And so I need to do I pose.
Oh, I pose and everything afterwards. So that's why I included the colon form.
Plus 1. So let's see, I'll just sort of advance past this little colon character and get into that space. Okay. So let's run it. So now I've got space 08475.
Oh, it should be plus 2.
Now I can just see it. Value equals float of piece.
Oh, crap, I forgot to do the float thing. Float. No. Value equals float. Opos. We're going to have to get rid of the type opos just to see. Does it say? Do I just do print type opos? Yes. Still a string. It's still a string. I'll have to do that. Get rid of white space thing. What was that, split? Spaceless equals split opos. print spaceless. It's not split. I don't know what.
Because piece is a string. It's a string, and then I'm going to say print value to see if I got the value right. And let's remember that there's a space here. This might mess up float. I don't think it's going to mess up float, because float's trying to find a floating point number, and it kind of, but let's just see if it works. Let's just see if it works. Okay, so the key is it's in position, the colon is in position 18, the string we pulled out is blank 08475, and the floating point number is 0.8475. So we've sort of solved this. Now, I can clean this up a little bit by making that +2, so I'll just change that to plus.
What? Oh, I'm an idiot. Print value. Then watch this. Type print type value, and this will be a float. That's a float. I'm an idiot. That's the problem.
+2, and you'll see how that changes what I'm doing. And so now this here is the string, that one there is the string, this is the actual floating point number. They're the same thing, other than the fact that it's a floating point number and you can add something to it. So I could do something like print, value plus 42.0, and that would actually work, right? So 42 point, and if I did print piece plus 42.0, that will blow up, right? Because piece is a string and 42 is a float. And says can't.
What? Wait, where do you put that? Piece? I'm sorry.
I did print piece plus 42.0, that will blow up, right? Because piece is a string and 42 is a float, and says can't float, can't convert float object to string implicitly, okay? And so other than sort of taking out this extra stuff, I'm just commenting on a whole bunch of stuff here. Oops. So I take out all those print statements. These 5 lines are the lines to do this particular assignment, where we are tearing apart a string. And in the future, the source, this is just so that we can play with strings, but later we'll be taking this data from all over the place. Finally, we're going to start opening some files, and then later in the course we're going to be opening data from databases. We'll be opening data from the internet, and so there's all kind of sources of data where we get these strings. But for now, we're in chapter 6, and we're only focused on strings. So I hope you found this useful, and coming up soon, we'll be opening files.
Oh boy, man. Oh, I just feel like it's going to be a big deal. All right. Well, that is going to do it for today. It ended up being an hour stream after all. Good stuff. Good stuff. Thank you guys so much for watching. Leave a comment below if you have a prayer request or anything. You can comment, not just a prayer request. Like, you can comment anything you want if you want. No, I mean, a family friendly would be great, but it's a free country, I guess. But But I do not think I'll be streaming tomorrow. Got church in the morning, and then I'm meeting with a buddy of mine in the afternoon, and then evening I don't want to stream because then I'm meeting with the another buddy of mine in the morning on Monday, and so I might be streaming in the afternoon. I don't know how that's going to look on Monday, but we'll see. So we'll be back at it Monday, opening files and whatnot. But thank you guys again so much for watching. Please like and subscribe if you want to. Love God, love people, and I will catch you guys Monday.